In today's short video, we're going to take two temperature sensors and a pH sensor, and we're going to couple that to our Arduino. Then we're going to upload that data to ThingSpeak, our cloud server, and you would be able to, on your phone, see the temperature readings as well as the pH readings. This is part of a whole series of videos on the Arduino microcontroller in Aquaponics and Hydroponics. So let's start right away. So let's have a look at our system block diagram. Again, we start with our Arduino Uno. Then we add our first temperature sensor, our second temperature sensor, and a pH sensor. That data will then go into the Arduino Uno on the analog ports A1, 2, and 3. And we will then send the data to a ESP8266 Wi-Fi module. Module will then communicate that data via your Wi-Fi system to a cloud service called ThingSpeak, where you can on the internet, then on your PC, have a look at the data. And from there, we will also send that data to an app on your cell phone where you can have the data with you all the time. So you may ask, how do you power your Arduino board? And there's basically two options. The first is with a normal cell phone charger, and you use the same cable that you use for your programming, and you just plug it into the cell phone charger and the other part into your programming port, which also supplies your Arduino then with 5 volt that it needs. The second option is to use a DC adapter, something like this, and with a pluggy like this, and you then plug that into your DC port. This port can handle 7 to 12 volt, so any decent DC adapter, 7 to 12 volt DC adapter you can use to plug in there and to power your final project. You can then install your project with that supply. So here's our pH probe. I've just put it separately, but we'll put it with the other components just now. So you've got your probe, you've got your analog interface board, and from that you've got a positive 5 volt, a ground, and then on pin A3 you will put your analog output from the analog interface board. Let's have a quick look at our circuit. We've got our Arduino Uno. We've then got our ESP module. Let's check the connections of the ESP module quickly. RX of EXP to TX of Arduino, TX of ESP to RX of Arduino. Then common ground for the ground of the ESP module. Your VCC of your ESP module, very important, go to 3.3 volt. Then reset and CHPD is also connected, like you can see here, to the VCC pin. Also your capacitor is coupled close to your ESP between the VCC and the ground of the ESP module. The capacitor, of course, to stabilize the voltage during short bursts of transmission of your ESP module. Then we go to our two temperature sensors. Our one temperature sensor and the other one. Between that sensor and between that sensor's middle point and ground, you've got a 10K resistor. Then from there you've got the sensor, and to the top is to 5 volt. And then from the center point between those two, you've got your wire that goes, in this case, to A2. So this is temperature sensor 2. This one exactly the same coupling, but your wire is going to A1. So this is temperature sensor A1. And then all that's left is our pH probe. So you'll see our pH probe is at A3, and that's going to the pH board's analog output. And then, of course, you need your 5 volt positive, which is from that rail there, and our ground to our pH board. So then you've got your 5 volt positive, and you've got your ground that goes also to your pH probe. Let's start with our build, and we're going to start with our ESP chip. So I'm first going to put the connector of the ESP chip on the breadboard. Then you will see that VCC reset and CHPD must be connected together. So we're just going to bridge them out on the breadboard. So there's VCC and reset, and I'm going to put another link on for between reset and CHPD. So there's it, another link there. Alright, and then we can take that VCC, let me just get a wire, we can connect to the 3.3 volt of our Arduino board. Make sure you put it into the correct place there. Then the ground of the ESP chip we can connect to our system ground, and let's put our system ground on this rail of the breadboard. Remember, if you do not know the breadboard, the connections on the breadboard, please check previous videos where I explained that. So the next thing would be to connect our RX and TX. So TX of the ESP chip go to RX of the Arduino, that's pin 0, and then RX of the ESP chip goes to TX of the Arduino, that's pin 1. Alright, so we've basically almost finished with our ESP chip. Just one thing that we must add there is our electrolytic capacitor. Remember, the electrolytic capacitor has got a negative part that must go to ground of the ESP, and the positive part must go to the VCC of the ESP. So I'm just going to put this one on ground there to get it into that VCC, and just make sure that it's into the ground as well. So there you go, capacitor is in. And our next thing is our two sensors, our 10K thermistor. So let's start with that. We're going to connect the 10K thermistor between VCC and our, let's make this our VCC rail here, our 5 volt VCC rail, and our 10K resistor, and just put them together there, and we go to ground with that pin. Then the next one as well, another thermistor, also to VCC, and let's put it there. And then we take our other 10K resistor and we just go to ground from there. Right, now that center point, let's make this our thermistor 1. Thermistor 1, this one. So we're going to, just where the resistor and the thermistor legs are connected, we take that then to a, let me see in the software, A1. We connect that to A1. Alright, and then the other one as well. So we can take the second thermistor, just put it together there. The second thermistor, where the thermistor and the resistor is connected, we take that then to A2. You will see that's also in our software like that. And then we get to our pH probe. Now here's our pH probe. So I'm just going to put it here to the side, and you'll see this is our analog interface board of the pH probe. The analog interface board again has got a 5 volt VCC that we put on our 5 volt rail here, and the ground, which is a common ground, we put on our ground, and then the analog output value of the analog interface board we put to A3 like we've specified in our software. So now we still need to connect. Now remember, this is our 5-volt rail that we've specified here. So we're just going to put a wire from the 5-volt rail to our 5-volt pin on our Arduino. Alright, and then we still have to connect our ground. So we take a wire for the ground, which is this bottom rail here. So we just put it in there and we take that to ground. So you can see there's the complete connection with the two thermistors, with our pH probe, everything connected. Very easy to do that. Keep your connection diagram open next to you when you do that. Go to that part in the video. I'm going to go into a little bit more detail into the software today. So the first part of the software here, you can see that it's 2 forward slashes. Everything behind that, like we've said in the past, is just comments. So I've given a few comments here at the top. And then after that, there's a few things that you must change in your software. The first thing is the name of your Wi-Fi network. Then the second thing is your Wi-Fi password. You put it in there. And then the next thing is the channel key. This one here. Very important, you must get this channel key from ThingSpeak. So if we go to ThingSpeak here, you will see API keys. You can just press on that tab and this will take you to your API keys, and this is the API write key. So you just copy this key and then you will go back to your Arduino program. You will just from there until there paste the key in, and that's the key then, so that your Wi-Fi knows exactly where to go and put the data. The next point here is your time interval between your samples, and you will see I've got it at 1 second here for just for test purposes now, but you will typically change this to the amount of seconds for 10 minutes or for 15 or for 20 minutes, depending on the sample interval that you want to use. The next thing here is our ThingSpeak IP. Now this IP address stays exactly the same, you don't bother with that. And then we've defined a few variables. You can see that temperature 1 we've put on the A1 analog port, temperature 2 we've put on the A2 temperature port, or the A2 analog port, and then our pH we've put on analog 3. And then again a few variables that we work with. Here's our calibration factors for our pH probe. Please check the video on the pH probe to see how to calibrate it. I'm not going to do this in detail in this video. Please check the video on the pH probe if you want to calibrate your pH probe. That must be done. The next part is the setup. So this is our serial communication baud rate at 115/200. Please make sure that you put your serial monitor to this baud rate as well. At the bottom of the serial monitor you'll find that. Then there's just a little test to test if our Wi-Fi module is working, our ESP8266. So the next thing is our main loop. Remember, all my software I write in the form of functions that I call from the main loop. There's 4 main functions that I call from the main loop in this case. First I will get the temperature 1 value, then the temperature 2 value, then I will get the pH, and then I will send that via the Wi-Fi, and then I will wait a certain amount of time. Remember the time that you've set at the top, that variable is going to be placed in this time as placeholder. Your delay is always in milliseconds. So this is why it's 1000 times the variable that you've defined in so to get to seconds. And then we've got our different functions. Here's the pH function. You will see if you click on the first bracket below that and you move down, the last bracket of that function will be just indicated by the IDE, like you can see there. So everything in between there and there is part of that specific function. What we do in the pH function, I take 10 readings and then I average them, and then I do a calculation to calculate exactly the pH value, and I put that value then into this variable pH value. Right, let's move on to temperature 1. This is the next function. Again, it starts there, it ends there. This one will read the temperature on this analog port. Now remember, temp 1 at the top, we've set that to A1. So it's going to read it on A1, then temperature 2 exactly the same. So it's going to read it on this analog port, temp 2, which is A2. And here's our send function. Our send function will do a certain amount of things in order to send that data to via the Wi-Fi to the cloud server ThingSpeak. Now I just want to bring your attention to something here. Here's your different fields. So you'll see that's field 1, field 2, field 3. I've commented out field 4 to 8, but you can always add this in if you've got more sensors that you want to read from and send data to ThingSpeak. And let me show you here, that line will stay the same, this one will stay the same. And then here, can you see I've put the variable for temperature 1 in here. I've put the variable for temperature 2 in here, and I've put the variable for the pH in here. So those variables will be sent to those fields in ThingSpeak, and then we just end off the AT commands communication to the Wi-Fi module, and that's then the end of this function. Here you will see Wi-Fi connect function. The Wi-Fi connect function is called in this send function. Right, so all in all, a very simple program. You can then just compile it and see if it compiles, and you can see it's busy compiling, done compiling, so there's no errors in your program. Normally, if I do any changes to a program, I will immediately compile to check for errors and then fix that errors before I move on. So we're ready now to upload to the board. And just remember, your RX-TX wires on your Arduino board, you must lift those out before you upload to the board, because the communication here is also happening here on the wire. That's the serial communication for the Uno, and if you leave these wires in while you program, then it will not program correctly. So I'll just lift them out there, keep them there, and then do the upload. And you'll see it's uploading. It's done upload, and we can push our wires back there. Right. So now that program is running on our microcontroller, and we can now go to ThingSpeak. So there you can see the data coming into ThingSpeak for temperature 1 in field 1, temperature 2 in field 2, and then our pH here. And you can see I've constructed a gauge here for the pH. There's a specific video on ThingSpeak where I tell you most of the stuff that you need to know here and how to construct this gauge as well. So this is our pH readings as they come in. There you can see one just came in. And then let's take our temperature, and I'm just going to touch the temperature sensors to heat them up a little bit so that we can see that data from the temperature sensors rising. And there you can already see some movement in the temperature sensors, in the temperature that's read by our Arduino system. And there you can see the temperature moving up. So your system is now 100% working. You're logging your pH. So you can also make gauges for your temperature 1 and temperature 2 in ThingSpeak. I just want to show you how to work with the ThingSpeak apps on your Android phone. So you can just go to the Play Store and then you can just type in ThingSpeak. And you'll find a whole range of apps that you can use with this system. I'm using two at the moment, ThingViewer and ThingShow. So I'm just going to show you ThingShow. So here you can add a channel, so you can just press that plus. I'm going to add my public channel, and then I need the channel ID. So let's go to the channel itself, and at the top of your channels you'll find the channel ID of that specific channel that you want to show in the app. So this one is 432244. So I can then just go there, 432244, and I can open that. It will then tell me, alright, there's 3 different fields in that channel. I can just go ahead, and now you can see my channel appeared there. So if you just press on that channel, then it will open and you will be able to see your data, and you will see that it correlates with your channel. So there's the channel, and there's it on the phone. Now, after your project is working, you can take it and you can just build it on a Vero or a strip board. You can maybe put it in a little box like this one. And another thing that you can do is, if your project is in your system, you can just plug out your pH probe. And you can plug it in when you need to take pH readings. Remember, pH probes does not have a long life. So if you leave it into your system permanently, it would not last longer than about 6 months. You can just check the manufacturer specifications on the specific pH probe that you use. But I normally take my pH probe out of the water, and if I want to do pH readings, I put it in the water. The data is nicely locked to the cloud, so I've got a record of that, but otherwise the probe is not in the water. You can also check out the videos on the screen right now. I've also linked the playlist there for you for the other Arduino videos. If you liked this video, if you found any value in it, please like it, subscribe, and I will see you in the next video. Thank you and bye-bye.